set. Now, in terms of our finite set, so let us look again at that word finite set. And it comes right away from our English definition, the word finite, okay? Our finite set, it says right away, it has an ending, okay? We can see the beginning and we can see the end. So that, for example, this set A would have been equal to a finite set because we know the last member of that set. So as long as we can see the last member of any set, it is called a finite set. It has an ending. All right, and so you're right then. If the finite set is one where we can see the last number because it has an ending, an infinite set is one where we cannot see the last number. So if we had an infinite set B, it would have been going 2, and we could have been going, let's say, 25, 30, and 40, and somebody could put that, and we don't know what the last number is, okay? And that is what we call an infinite set. We don't know the last number, okay? So it has no ending. All right, now after that, so we can have finite and infinite set. When we have our finite and our infinite set, it means we have elements or members in that set. But surprisingly, and we have to say this quietly, for us, there is also a set that we, in our human industrial capital world, do not even count, but it exists. And this is the empty or null set. Okay? So yes, there is a set that we do not look about or even talk about when we are addressing certain issues. But in terms of combination and permutations of stuff, it is there. And so, in dealing with this topic set, we have to take account of it. So, the null set, and we call it a null or empty set, because it has no numbers, no members, okay? The null or empty set has no elements. Let's use our set language. It has no elements. And instead of elements at time too, yes, interchangeably, we can use the word no members, okay? So element, so it has no element. The notation for our null, let's get rid of these things so that you can see this one.
If you know the answer to a question is incorrect and you cannot find the mistake, start over on a clean piece of paper. Oftentimes when you try to correct a problem, you continually overlook the mistake. Starting over on a clean piece of paper will let you focus on the question, not on trying to find the error. Always read math problems completely before beginning any calculations. If you glance too quick at a problem, you may misunderstand what really needs to be done to solve the problem.
The notation for our null or empty set is just this. There are two ways. We can have it like this, or curly brackets. Or curly bracket, that means the null or empty set. Or we can get, you are writing like an O and you're crossing it. Okay? So we have two notations, either or. You can use this one or this one. And that represents our null or empty set. It has no members, no elements. So when a child writes this and puts 0 in it and says that that refers to the empty set, it is wrong. All right? It is wrong. Okay? This represents a set with one element. So please note that difference immediately. 0 putting in a set notation does not mean an empty set. An empty set has a curly bracket with nothing in it, or you write something like an O and you cross it. But if you ever write this, then that is wrong. All right? So from the beginning, please note that. Now, in terms of the examination bodies, because I know around the world we can have different representation of what they would be using for universal set. And quite conveniently, when we start thinking about the universal set, we just use the first letter of this word, okay? So here in the Caribbean, in terms of our CSEC examinations, most of the time, we're going to get that the universal set can be represented by, sometimes I like to call it an upside down, an IU, okay? And without any sort of tail or anything. And that is called our universal set, okay? Because at times we knew we would have been seeing it with this sort of big capital letter E. So just look and see. So it is interchangeably. There's no one standard representation or notation for the universal set. Just depends on who is the examination board and what they're using. But they will actually tell you the symbol, whatever, represents the universal set. But usually for most of the writers and the textbooks that we have been using, we are using U to represent our universal set. And the universal set for any specific set on the discussion is exactly what it signifies, in the sense that universal means that we're talking about everything in this particular set. Okay, so everything in this particular set would be called the universal set. And the universal set is distinguished in that sense because we can have subsets from this universal set. Subsets from this universal set. So for example, if I was going to say that this, the universal set is equal to 1, 2, 3, 4, 5, 6. If I give somebody universal set and say that is equal to 1, 2, 3, 4, 5, 6, I can take some subsets, and when I'm talking about subset, a subset from that universal set can be represented by one of the elements, one or more of the elements from that universal set. So for example, I could have been getting a subset where I would have 1, and that's a subset. I could have used 4, and that's a subset. Or I could have been using 1, 4. All right? So any combination, we can have 5, 6, and 1, okay? And any combination of these elements from a universal set, and we take some or one member of it, it is called a subset of that universal set. So a universal set only exists to deal with the specific set that we are dealing with at one time in a particular question. And then the subsets can be derived from the universal set. Now, sometimes it is challenging, and sometimes we want to know how many subsets can we actually form from a specific universal set. And sometimes we keep our students and we ask them to tell us the number of subsets that we can get in this particular set. And they would be sitting in a classroom, and of course we would say 1, and then they can do 2, 3, 4, 5, and 6, then do the different combinations. But do they ever know when it is sufficient, or that they have actually listed all of the subsets? Yes, they can, because there is a formula that we would use to say the number of subsets in any set is equal to 2, and we say 2 to the n, okay, is equal to 2 to the n, or it can be any little thing, but 2 to the n, where n represents the number of elements in the set. The number of elements in the set. So for example, for my universal set here, I would have how many members? 1, 2, 3, 4, 5, 6. So if I wanted to find the number of subsets, it would have been n then would have been equal to 2 to the 6, okay? And 2 to the 6, again, we get into our indices, and it would be equal to 2 times 2 times 2 times 2 times 2. So it's 1, 2, 3, 4, 5 times 2. And if we know that that then would be 2 to the 5th is 32, so another 2 would give us, the answer is 64 of them that we're supposed to get. All right? Okay, so this is what we have been doing for today. So far, in terms of the things that we have to do for our sets, we got as far as the first things that we can define a set. We know the element or number of elements in a set. We know a finite set. We also know an infinite set. We know the null or empty set, the notation. And we are not going to put 0 in a bracket and call it an empty set. We understand how to identify the universal set, the subsets, and the number of subsets in a set. When we come back, we will tell you how you get on to start talking about equal sets, equivalent sets, Venn diagram, and the others that we have listed before. So see you then.
Join us next time for another in the series, Mastering Mathematics, a production of the Education Broadcasting Unit in the Ministry of Education and ABS TV.